Welcome to this video on equivalent fractions using circles. In this video, we'll be using equivalent fractions using circles in reference to the fraction wall we used in our previous video on equivalent fractions with bar shapes. Now let's look at one whole. Now let's look at halves. We have that 2 halves makes a whole. So we have 2 over 2 is equivalent to 1. You'll notice there I've used the symbol equivalent, and this is what I'll be using for the rest of this video. Now some books will have them as equal sign, which is relatively fine, but I thought we'd introduce the symbol equivalent this time around, since we're working with equivalent fractions. Now here we have 3 of 1/3 is equivalent to 1. So we have 3 over 3 is equivalent to 1. And in this case, you can see that 4 over 4 is equivalent to 1 because we have 4 of 1/4. And this pattern repeats itself with 5 over 5 equivalent to 1, and it carries on till we get to 10 over 10, which is equivalent to 1. So as long as the numerator and denominator are the same, we have it equal to a whole. 6 over 6 equivalent to 1. 7 over 7 equivalent to 1. 8 over 8 equivalent to 1. 9 over 9 equivalent to 1. And finally, for our last example, 10 over 10 equivalent to 1. Now let's look at fractions that are equivalent to 1/2. Now let's see if we can find an equivalent fraction from a circle divided into 3 equal parts. Now we place that there, doesn't fit in nicely, so we can't make out an equivalent fraction from our circle that was divided into 3 parts. Now let's see if we can find an equivalent fraction of 1/2 from our circle divided into equal 4 parts. Now we place that on our half and it fits in nicely. We can get 2/4, which is equivalent to a half. Let's try the same with our circle divided into 5 equal parts. And nope, doesn't fit in nicely, so no equivalent fractions here. Next, we tried with our circle divided into 6 equal parts. And yes, we do have an equivalent fraction here. 3 over 6 is equivalent to a half. Let's have a go at our circle divided into 7 equal parts. And no equivalent fractions here. Now we tried with our circle divided into 8 equal parts, and we have 4 of our 1/8 that's equivalent to a half. So 4/8 is equivalent to 1/2. We try this with our circle divided into 9 equal parts, and we see with our 1/9, no. And now let's finally try this with our circle divided into 10 equal parts. And we'll place that there, and we see that we have 5 of our 1/10 is equivalent to 1/2. So 5 over 10 is equivalent to a half. Now for the next one, we're looking for fractions that are equivalent to 1/3. And we'll place that. This is our circle divided into 4 equal parts, and no equivalents here. Try the same with the next one. All in 1/5 and no equivalents here. We tried this with our circle divided into 6 equal parts, and yes, we do have an equivalent here. So 2 over 6 is equivalent to 1/3. We tried with our circle divided into 7 parts, and nope, equivalent fractions here. Next, we tried with our circle divided into 8 equal parts, and no equivalent fractions here. And we try this with our circle divided into 9 equal parts, and yes, we do have an equivalent here. We have 3 of our 1/9 is equivalent to a third, so 3 over 9 is equivalent to 1/3. And trying with our circle divided into 10 equal parts, and no equivalent fractions here. Now we'll carry on doing the same with our 1/4 and 1/5, and we'll find out that it summarizes that for our 1/4, an equivalent is 2/8 is equivalent to a quarter. And for our 1/5, we'll see that 2/10 is equivalent to 1/5. Now here's a summary of our equivalent fractions based on our fraction wall using circles. Well done. Keep on learning. Don't forget to click the like button, press the notification bell, and subscribe for more of our daily videos.